Hi guys, welcome back to my channel. I am recording what will be the last official video in the reduce series that I'm making. This the video series about the method reduce on arrays. I made a series because I wanted to show multiple uses of this wonderful JavaScript method. Now this will be the last official one in the series, but if I come up in the future in my job or in my projects with any other out-of-the-box use of reduce, then I will probably record another video at some point in the future. Now if you somehow stumble into this video first, I will link the first video in the series right here at the top, and make sure you watch that if you are new to the reduce method, just so you understand how it works. Otherwise, this video might go a little bit too fast for you if you don't know how the reduce method works. Okay, now in this video we are going to use reduce to transform an array to an array of items to an array of arrays. And how would that be useful to you, you might ask? Well, let's imagine you receive from your API, or you have somewhere in your program a series of items, like an array of items. Imagine these numbers are not actually numbers, but are all of them are, excuse me, all of them are objects which contains multiple properties for an item, and that item will be basically displayed on a row in a page. So you're gonna have multiple rows, and you're gonna have the info for a row, like different value for that row in that particular. So in the first one, you're gonna have info for the first row. In the second object in the array, you're gonna have info for the second row, and so on, right? Now here I will just use numbers, but yeah, think about this, can be objects that contain information, right? And you might have all the elements in an array, and you need to split it by page, because if you have, like, for example, 100 elements, maybe you don't want to display them all on the same page. Maybe you want to like split it in pages of 15 per page, or maybe 5 per page, or whatever many you want per page, right? Unless you're doing like an infinite scroll. But if you want to split per pages, then you might want to split this into an array of arrays. So for example, if the page length would be 5 per page, then you would get an array with five elements in the first array, another 5 elements in the second array in the array, and then the last one will be left with 3 elements, because you have 5 per page, but you don't have 5 in the last one, because that's what's left, right? So with we're going to make a function. I'm using an arrow function, so if you don't know how to use arrow functions, go and look them up. But this is how our function looks. You have this and you return this, and because we're only returning one value here, we don't need to use this. We can just return the value like this, and we're basically gonna get the history. Well, history, maybe this is not called appropriately here, so let's name it something else. Let's name it items, right? I think that's it. Items. It was called history where I used it, right? So you have items, and which is the array with items, and then you have the page length in which we want to split that array of items. And here we're going to use the reduce method as explained in videos from previous videos in the series, and we get an accumulator, which can also be called short you can give it a short name. You can say something like that. And if let's change everything here, let's change everything where is accumulator. We want to change to this, right? And current value we want to change just to var, right? Okay. And we also need the index of that item in this use of reduce. We're gonna need the index in the array of that element. So what we're going to say is we're going to say const current history index equals with parse int of index, the index of an element, divided by the page length. And why we're doing this is because here what we're going to create is we're going to create the index of the array in which the current element will be located. And the way we do that, we're going to use the index and we're gonna divide it by page length, and that's how we're gonna get the index, because basically you have to divide it, because that's how many per page. Because imagine if you have for example you have the third element in the third element in an array, and you have the page length 4, 3 divided by 4, and parse int 3 divided by 4 is like less than well, it's 0 point something. So if you use parse int, it's going to be still 0. So the third element is going to be actually the last one in the first array that is created within the array. And once we're going to the fourth element, then we're going to get 1. So the fourth element is going to be put in the array at index 1, so the second array, right? And don't worry if you didn't understand that. I'm going to go through a complete example of how the values are here at the end, right? And then what we're going to say once we find out what's the index of the array in which this element should be located, we're going to say that that we want the array at that index to be either the array at the element of that index, if it exists, or empty array. So we're going to say we want this one to be this one if it exists, so it remains the same if it exists. If not, it is created, and it is created as an empty array, right? And then once we have created it, or we have left it as it is, we're going to push the value in that array, because their value needs to be pushed in the array at that index, right? And then we're returning the accumulator. And I'm not explaining how reduce works here, because you should have watched the first video to understand how that works. But yeah, this this is the end here, and I'm going to show you an example. I have here, I'm saying const item split into pages, and I'm saying split history into pages of items, and the page length will be 4. And if I run that, you can see that we get split those 13 elements into this array, arrays of length of 4, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10, 11, 12, and then 13 is left on its own on the last page. And if I change this to 7, for example, then we run again, and we get an element of length 7, and then the last element is of length 6, because there's only 6 elements left. And if we try 5, for example, again, we're getting the correct answers. We get one array of length of 5 inside, another one of length of 5, and the last one of length of 3. And now, if you didn't understand exactly what's going on here, I'm going to create one short array, like with 5 elements maybe, and I'm going to basically go through all the steps here one by one, because this is basically a loop and it goes through the values. So let's see what's going on. Let's hope this is not going to be too difficult to show all the iterations, right? So we're going to have here 1 2 3 4 5 and page length, and I'm going to put page length 3, right? And this is what's going to happen. Basically, now this shows some errors because this is not how it's supposed to be, but this is what's going to be on. First, because we have put here to start with an empty array, first the accumulator is going to be an empty array. The first value is going to be 1 because it starts with the first value, and the index is going to be 0, right? Because we're starting with index 0, so that's the index of the first element, as you know, in arrays, right? Then we're going to say const current current history index equals to parseInt of index divided by page length. And what's parseInt of index divided by page length? So index is 0 divided by 3 is 0, so parseInt of 0, it will be 0. We're gonna put it here, so this is gonna be 0. Then we say accumulator of 0 equals accumulator of 0 or empty array. Now, do we have an accumulator of 0? Do we have an element in this array at the position 0? We don't have, so what we're going to do is we're going to create it. So now accumulator of 0 is going to be an empty array, right? So the accumulator at this point is an array with an empty array at position 0, right? So this is what's going on at this point. This is the accumulator. Now it says accumulator of 0 push value. So we push the value is 1, as you can see here. So we're pushing it in this array because it say accumulator of 0, which is this one, push the value. So we push the value, and accumulator is going to be now, excuse me, Control X. Accumulator now is going to be like this because we have pushed the value 1 in here. So this is the accumulator, and now we are returning the accumulator at the end. So once we return it, the loop starts again. Now the accumulator is going to be whatever we return. The current value is going to be 2, right? So 2, and the index is going to be 1, right? We're doing this again. We have index divided by page length. Index is 1 divided by page length 3 is 0 point something. ParseInt of 0 point something is still going to be 0. Then here, accumulator of current history index equal accumulator of current history index or empty array. Now, do we have an accumulator of current history index which is 0? Do we have an accumulator of 0? Yes, we have. So we already have this array, and it says, okay, if we have this array, then just leave it like this. And then here we're saying accumulator of current history index, which is 0. So accumulator of 0, push value. The value is 2. So basically we push the value of 2 in the first array. So now the accumulator is going to be like this, right? So once the accumulator is like this, we return it, and now the accumulator becomes this because it goes in the next iteration of the loop. Then the value is 3, right? And the index is 2. Now index 2 divided by page length, 2 divided by 3 is like 0 0.66. ParseInt of 0 0.66 is still going to be 0, so we still keep 0. Now, do we have an element at position 0, at index 0 in the accumulator? Yes, we have this array at position 0, so we keep it like this. So here nothing happens, we just keep it like this. And then we pushing value, which is 3, in the accumulator at the index of 0, right? So now the accumulator, and I know that like we're getting this step by step, but I'm just going through it just so you understand what's going on. Okay, so we're basically pushing 3 the current value in this array, right? We're pushing the value, right? And now the accumulator is this, and we return it, right? So we return this. The accumulator is becoming this, right? And the value becomes 4 because it goes to the next one, and the index it becomes 3. Now we say index divided by page length. Now index divided by page length, so 3 divided by 3 is going to be 1. So now this, the current history index, is going to become 1. So now do we say accumulator of 1 equals accumulator of 1 or empty array? Do we have an accumulator of 1? No, we don't have. We just have accumulator of 0. So because we don't have, we create a new element at position 1, so the second element, and we create it as an empty array. So at this point, the accumulator is it's in an array with an array like this and an empty array. And then we say accumulator of current history index, which is 1 at the moment. We want to push into it the value, which is 4. So now, at this point, because we're pushing 4 into it, this is the accumulator, and we're returning it, right? So we get this, and this becomes the new accumulator. And then this changes to the last one, 5, and this changes to 4. The index is 4, right? So now we're saying the index of 4 divided by 3 is 1 point something, right? 1.33. Percent of 1.33 is just 1, right? So again, it stays 1. Now it says accumulator of 1 equals accumulator of 1 or empty array. Now we have an accumulator of 1, is this one, so it remains the same. Nothing changes now. But then at accumulator of 1 into accumulator of 1, we want to push value. So into this one, we want to push value, which is 5. So now the accumulator becomes this, right? So now we have reached the end of the array, and this is what it will be returned, right? This, you can see how all the steps are happening, right? Now I'm going to go like a lot of Command Z, Control Z to go back, and you will see this is exactly what it returns, because you have seen before, right? So we go back. Okay, I think this should be it. Oh, we have to change this here as well. And if we put here items entry clear, and this is exactly what it returns. Okay, now I made this one like really easy to understand. I hope you did understand it, but if you got stuck somewhere, please leave a question. And if this video helped you, please give a like and subscribe. It helps with the YouTube algorithm, and it helps these videos to get to more people. All right, have a good one. Bye bye.